Hey, and welcome back to the Assembly and First Principles playlist. So in this video, we're going to be actually building the XOR gate, which is an exclusive OR gate, meaning that we're going to be having two inputs, and it's only going to output true if just one of the two outputs are false. So it doesn't equal true like in the traditional OR gate when both are true, and it doesn't output true if none of them are true. So we're going to look at this circuit right here. A good trick to building these gates without having to rely on these Boolean algebra statements is that you can Google or look in the lectures for the implementation circuit, and it just gives you an outline of what type of gates we're going to need, and you can kind of walk through the logic when you have the circuit, and see that okay, an input is going to be passed into these gates first and then into these gates. So you can kind of build your code in a linear fashion that way. So the first thing we're going to need is two NOT gates, two AND gates, and an OR gate. So we're going to go to our XOR file in project one, and we're going to start building here. So we know we need two NOTs. I keep forgetting that. Python. Two ANDs. And one OR. So the OR ties it all together at the end. So in both these NOTs, we know this takes in two arguments. So we're going to have input A and output is not A. And input B and output equals not B. So let's go back to the diagram. So if A, it's being passed into a NOT gate into the same AND gate that the true B is being passed. So we're going to have NOT A and B, or we'll start out with A actually, A and NOT B into the first AND gate. Actually, we have to A equals A and B equals NOT B. And then for our output, we're going to have C1. And for our next one, we're going to have A equals not A and B equals B, and output is equal to C2. And then in our OR gate, all we're having is just the outputs from the AND gates, and it's passing into an OR gate. So we're going to have our A equals C1, B equals C2, and out equals out. So I hope that makes sense. It like as you sort of build these up, you kind of get a more simplified understanding of how these works. And I should have stressed how much easier it is to work with a circuit diagram, because it's I don't know about you, but I like the visual representation of it. You don't have to kind of decipher, okay, this is passing into this is passing into this. You kind of just see, okay, so for this AND gate, I need a true A and I need a false B, and then kind of do it that way. Before I was kind of like deciphering through those statements of implementation. So we're going to save this, and then we are going to launch our hardware simulator and do what we normally do, which is load a chip, XOR, load that chip, file, load a test script, and our XOR test script, and we'll run it. So we'll just take a look at the compare and the output file just to show you the truth tables are correct. You usually don't have to do that when the comparison ended successfully because it would have thrown an error. So as you can see, this is our XOR output truth table. We have 0, 1, 1, 0 equaling true, and the other ones equaling false, the same as the compare file. So that is the XOR chip. I'll try to break these down into singular videos on the chips, just so you can kind of digest it all. Again, going back to this, you can see that in in like a real circuit, you would have these, I guess, on and off switch that would just turn it to be true, like a full connection and a not full connection. And you can see here in an actual circuit that um, this is how it will be implemented. And yeah, it's just kind of I would read through these slides, and if you want to get more in depth, there's a book associated with the website. And yeah, it's um, it's going to get a bit more complicated in terms of the complexity of the chips, but they allow you to do a lot more cool things, like a multiplexer allows you to sort of that would be kind of our first look at a chip actually making a more complex decision when you have a selection, like you have a selector bit that allows you to select which output that it's going to force through given a certain amount of inputs. But yeah, I hope that XOR video is helpful. I know it was a bit shorter than the other ones, but we're going to try to keep these brief and to the point. So thanks for watching.